Good morning, friends. Today we are going to deal with this particular basic nuclear properties. Here we can see, we know that particular all nuclei will consist of the two kinds of the particles that are bound together and are spherical in shape. There are the protons and the neutrons. Protons have the positive charge, whereas the neutrons are the neutral one. All nuclei are positive charge, and the magnitude of the electric charge is the integral multiple of the proton charge. That you have to MCQ will be there based on this particular thing, is that the all the nuclei are dot dot charge, positive charge, and the magnitude of electrical charge is an integral multiple of the proton charge. Atomic number of nucleus is nothing but the number of protons that it have. This is sometimes called as the charge number also. Atomic number of the nucleus is also called a dot 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 charge number. The neutron number is the number of the neutrons, and the mass number is equal to the total number of particles, that is the neutrons and the protons present in the nucleus. That you have to remember. It may come for the MCQ that yesterday I also said. Okay. Then first property we have to talk about the composition. Then here you can see the nucleus made up of the protons and the neutrons. They are bound together. If the alpha particles are there at that time, there will be the two protons and the two neutrons will be there in the nucleus, whereas the carbon is there. You can see here example, in the carbon there are the 6 neutrons and the 6 protons are there. Okay, and they are bound together by the force called as a strong nuclear force. Then the charge, the nuclear atoms are composed of the protons and the neutrons occupying the small region at the center of the atom. The protons have the positive electrical charge, whereas the neutrons are the electrically neutral. That already we have seen. The electrons of atoms are electrically negative and have a charge equal in magnitude to that of the protons. As a result, atoms of the elements are electrically neutral. Therefore, the stability of the nucleus cannot attribute to electric attraction. Then what happens? Therefore, the stability of the nucleus cannot attribute to the electric attraction. On the contrary, it is likely that the repulsion between protons would break up the nucleus. The fact that the nucleus exists clearly indicates the presence of the another interaction besides the electromagnetic interaction. This nuclear interaction is not directly related to the electrical charge and is very much stronger than the electromagnetic interaction. It is well known that the charge of the any nucleus is the integral multiple of the charge of the electron charge of the proton. That is we have seen already. That may come for the MCQs, and it is denoted by the ZE. Every integer Z corresponds to contain the chemical element. In atomic physics, the nuclear charge of an element can be easily inferred from its chemical and spectroscopic properties. The size, that anomalous scattering was observed by the Rutherford in the 1919 when the alpha particles were scattered by the highest element. This scattering was different from the pure Coulomb scattering. In this light element, the closest distance approach was approximately 5 into 10 to minus 15 meter. The distance of the closest approach at which the anomalous scattering begins was identified as the first measurement of the nuclear radius. It is evident from the experiment that the nucleus is composed of the protons and the neutrons, only known as the nucleons. Collectively called it as a nucleons. The shape of the nucleus is taken spherical because of the given volume. This shape possesses the least surface area and thus provides the maximum short range binding force between the nucleons in the nucleus. Then small asymmetries of the distribution of negative charge was present in some nuclei, as their nuclei exhibit high electric quadrupole moment. In the most of the nuclei, elliptically is only the order of 1%. Thus, we may suppose that the protons are uniformly distributed inside the spherical nucleus. The shape of the nucleus is the spherical in nature, that you have to remember. Okay. There is an experimental evidence that nuclear density remains approximately constant over the most of the nuclear volume and then decreases rapidly to the zero. This means that the nuclear volume is approximately proportional to the number of nucleons, that is a mass number. Here given volume is equal to 4 by 3 pi r cube. Our nuclear radius is equal to r is equal to a raised to that nuclear radius are directly proportional to a raised to 1 by 3. Here you can see how the nuclear radius has been calculated or say estimated. Okay, but we are not going in detail of this particular. Rutherford's scattering experiment is used to estimate the nuclear radius of the atom. Okay, that may come for the MCQs. Which experiment? Rutherford's alpha scattering experiment. Not only the scattering. Okay, we are not going in detail of such a things. Here the electron scattering has been shown. Then we have to talk about the nuclear density. Once you got that particular radius, you can calculate the density. You know the volume, then area you can calculate, and you know area by volume is nothing but the density. Nuclear density is almost constant and independent of the kind of the nucleus. This is called as the saturation of nuclear density. It is one of the remarkable properties of the atomic nuclei. Okay, mass defect. The nucleus is constituted by the nucleons, that is the neutrons and the protons. Hence, it is observed that the mass of the nucleus is always less than that the sum of the masses of all the nucleons present in the nucleus. Difference in the sum of the masses of all the nucleons present in the nucleus and the nuclear mass is called as a mass defect. Mass defect is nothing but the, here you can see delta m is nothing but zmp plus a minus z into mn minus m zn, where m is the mass of the bare nucleus having the z number of protons and n number of neutrons. mp and mn are the mass of the proton and the neutrons respectively, and the mass defect is given by z mp plus a minus z. A minus z is nothing but, what is that? Atomic number and the, yes, z is the number of protons, n is nothing but the number of neutrons. As n is equal to a minus z, where a is the total number of nucleons in the nucleus. This missing mass would be converted into energy that holds nucleon in the stable nucleus together by the strong attractive force. This energy is also equal to the amount of energy required in separating nucleons from each other until they are very large distance apart. In other words, energy must be supplied to the nucleons to separate it into the individual constituent. This energy is equivalent to mass defect, is called as the binding energy of the nucleons. What is this will come? The energy which is equivalent to the mass defect is called as dot 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 of the nucleus. Binding energy of the nucleus. Binding energy, that will nothing but the energy that keeps the nucleons in the nucleus together in a bound state is called as binding energy of the nucleus. Okay, that may come for the MCQ. This energy is also equal to the amount of energy required in separating nucleons from each other. Therefore, binding energy of the nucleus is defined as the energy which must be supplied to the nucleus to break it into its constituent nucleus. That may come for the MCQ. Okay. Then binding energy formula is given. We are not going in detail of such a detail. Electron, their mega electron volt will be the unit. Binding energy is also expressed in the mega electron volt. That may come for the MCQ. Okay, here we will stop. Please go through this thing. I discuss the probable MCQs depend on this particular part. Here we will stop. Thank you.